Hello students, so I will discuss about the time independent Schrodinger equation, or this equation is known as the steady state because there is no term of the time. Okay, in the last video I have explained this time dependent Schrodinger wave equation term, so you have to remember there is a term which is there is a term which is represent the time, but in this equation we don't get the term which is represent the time, or we can say that there is no term with a there is no time term. Okay, so students, I have taken the equation is, as you know, the psi is equal to a to the power minus I over h cross et minus px. Okay, so I think you can study what is the theory I have written, so you can read. Okay, so as you know, what is the meaning? We want to eliminate this t. The focus is we want to eliminate this t because this equation is the time independent form of Schrodinger equation. So what we do simply we have separate this e to the power I e t by h cross and e to the power I p x upon h cross. It's okay. So let's say uh, when we separate this term, so this a to the power I p x upon h cross, we have say this is a psi. Let's say we have assumed this is a p or a, कुछ भी हमने assume कर लिया. So remaining term is e to the power I h I e h cross upon into t का इसमें multiply है. This is the term is t. So remaining equation is psi is equal to phi x e to the power minus I h cross upon t. So now what we do simply we have taken okay, dear students, remember this equation, this part is represent that position dependent function, and this is the position, this is the energy and time dependent. Okay, so let's say अगर इसको मैंने bracket में enclose कर दिया और let's say if I say this is a constant, so this is only the time dependent है ना. हम इसको assume करें this is only the time dependent है, but actual में ये energy और time dependent है. So now what we do, we have taken the partial derivative of this equation with respect to x. So what is the partial derivative? So del x upon del psi and e to the power minus I e upon h cross into t dot del phi x upon del x. Remember, there is there no time dependent, oh, sorry, there is no position dependent term. That's why this is remain behave like as a constant. Again, we do the differentiate same as like we have done in the time dependent form. So do the double differentiate, so del 2 psi upon del x square e to the power I h cross um, I e upon h cross t into del 2 upon del x square phi x. So okay, now same thing, we have taken the partial derivative with respect to time of this equation. So what is happening, del psi upon del t, now we have do the differentiate of this term. So जो constant है, this is the comes with the multiply minus I e upon h cross e to the power I e upon h cross into t into phi x. It's okay. Phi is the position dependent term, so this is behave like as in constant. Now what we do, as you know, the time dependent Schrodinger equation is I h cross del psi upon del t is equal to minus h cross upon 2m del 2 psi upon del x square plus ux. We have taken this value from the time dependent Schrodinger equation. So in the equation 14.2 and 14.3 tells about the psi square x upon del 2 psi upon del x square and del psi upon del t. So now we have putting the value in this time dependent Schrodinger equations. So equation is converted in the form, if we put the value del psi upon del t, so I h cross minus I e upon h cross e to the power I e upon h cross t into phi x. The same thing is happening is here. So हमने यहाँ भी insert कर दिया, and also we have putting the value of psi की value हमने insert कर दिया. So as you know, this is the term is constant, so उसको हमने just separate कर लिया. So remaining term is e phi x is equal to minus h cross upon 2m del 2 psi upon del x square phi x plus u phi x. It's okay. So व्हाट वी डू, हमने क्या किया इसमें जो एनर्जी वाले टर्म है वी हैव राइटिंग दस वन ब्रैकेट, सो वी कैन राइट दिस इक्वेशन इज एच स्क्वायर अपॉन 2m del 2 psi upon del x square phi x plus e minus u phi x is equal to 0. So as you know, this is the function. So we can change the function, as you know, the property of some integration or the differentiation. So we have replaced this function phi x with the psi x. Now this equation is convert del h cross upon 2m del 2 upon del x square psi x plus e minus u psi x. We have not, do nothing, just हमने phi x की जगह पे psi x, यानी phi की जगह पे हमने psi x को रिप्लेस कर दिया. So now this equation is converted in the form of del 2 psi upon del x square phi x plus 2m over h square e minus u psi x is equal to 0. So this is known as, okay, dear students, you can see there is no term of the t, या t का आपको कोई टर्म नहीं मिलेगा. That means this is the time independent Schrodinger wave equation. This is the 1D form. Let's say if we write in the 2D form, so this equation is convert as del 2 psi upon del x square plus del 2 psi upon del y square psi plus del 2 upon del z square psi plus 2m over h square e minus u psi is equal to 0. This is the steady state or time independent form of Schrodinger equation in the 3D form. Okay, so I will stop this video at right now. So the next thing is the postulate of the quantum mechanics. So I will discuss in the next class. So I think regarding the postulate, I will discuss. Okay, I will discuss not too much. I will discuss little bit about this postulate because this is the just theory. So I will explain. Okay. Yeah. Okay. So dear student, I think now you can understand very well what is the meaning of time dependent or time independent. In case of time independent, in the final form, there is no term is related to time. In case of Schrodinger equation in time dependent, that means in the final answer, your final equation, we got the some term which is related to the time. Okay. सो डियर स्टूडेंट, ये फाइनली हमको वेव फंक्शन मिल जाते हैं, वेव इक्वेशन, यानी कि जो इक्वेशंस हैं साई का यूज, साई के साथ में कुछ हमें इक्वेशंस मिले इन द टर्म ऑफ एनर्जी. ओके, सो नाउ आई स्टॉप दिस वीडियो.